Okay, everybody's eyes on this? A and B. I'm just kidding. What happened? Nothing. I do see, there's like, have you ever seen when it's not water but it looks kind of thick and syrupy? Like the liquid kind of ripples like that? I did see that. Kind of like oil would look, yeah. Only it's still pretty clear looking. Can you see what I'm talking about? It looks kind of heavy. Viscous, like jelly. Okay. So you need to write in words your observations about A and B. You should probably say it's still clear. You probably want to mention something about how it looks, however you want to describe that, like jelly, thick. Viscous is the science word for it. Viscous. You know, like syrup is really thick. Viscous. Yeah. Why don't I have that? Because I'm dealing with acid and I don't want to get it in my face. I lost C. Where did it go? One of the 5 liquids today is acid. I'm not telling you which one's which. Your job is to figure it out. Okay? I mean, yeah, don't do that. That's why I was telling you to be careful. Hey, Abraham, can you pass that back up here? Okay. So, did you write down your observations for A and B? Super. Now I'm going to add C. So, in this vial, I'm going to have A plus B plus C. And we're going to see what happens. You ready? Everybody's eyes on it? 1, 2, 3.
Nothing's gonna happen.
Okay, I'm messing with you again. Nothing happened again. It does still look jelly-like. It is still clear.
Will it kill a turtle?
It would definitely kill a turtle.
Yes.
Alright. I am going to mix these same things together but in a different order. I want to see if the order makes a difference. So I'm going to dump this in my waste bucket. Hey Solomon, want to bring me that big bucket on the floor right there, please? Thank you, my friend. Just a reminder, in this class we never put anything down the sink because it's too bad. Okay. So this time I'm going to do it in a different order. I'm going to do B and C together first. And I just like to remind you that B and C have been together already. The last time they had A in there with them. Okay? Alright, here we go. B and C. Nobody's going to die. Can you see it? Everybody ready? Eyes on the beaker. What the devil? What just happened? He turned Okay, write your observations. What do you see? What happened? It turned bright pink. Is that A and C? This is just B and C without A.
B and C.
What do you think will happen when I add A?
It's a pretty pink.
I know, so bright.
Who thinks it'll go back to clear?
The acid? Is B the acid?
Is B the acid?
Yeah.
Because you added B to C.
So B and C changed color, right? So we know for a fact that one of them is the indicator, either B or C, because that's what indicators do. They change color when they're in acid or base. But so far, that's all we really know. Either B or C is the indicator.
Who's D?
I'm going to put A in. Are you guys ready?
No. I bet you it didn't change the color of it back to clear.
You think?
Oh, well,
No.
smart. Yeah.
Your life.
What I say? What I
Abraham can predict the future. Miss Egus is magic, and Abraham's a fortune teller.
Black magic.
Why did that happen?
Magic.
I had an A to B and C. What if I tell you that the indicator we're using turns clear in acid and turns pink in base? Does that help you with more information? We just added A and it turned clear. And our indicator turns clear in acid. So what do you think A is?
Water.
Maybe A is the acid, maybe A is the indicator.
Liquid, that type of bleach.
Alright, now just to make it interesting, I'm going to add two more. D and E.
Yo, what's up with E?
What is up with E? What does it look like?
Water.
Looks like salt water. Why do you say that?
But it's not clear.
It's not as clear. Can you see through it?
Yeah, it's like a coconut.
Kinda, but not very well, right?
That's coconut water.
D and E. Please write your observations about D and E in your notebook. D and E. I heard that it looks like coconut water. Is that what somebody's saying? I'm gonna turn my page because I'm running out of space. Can you handle that?
Wait, the one that's like darker colored is it D or E?
The darker one is E. Alright. I have to take it over to the chemistry hood and let it evaporate. It takes a really long time, but yeah, it evaporates.
Yo, I'm not gonna drink that.
Okay, D and E. You ready? Are you ready? Are you ready? It does look like milk. Let's write down our observation. What does milk look like? D in and then add a D. Look like milk. Shake it. What do you see forming on the edge? Can you see what came up on the glass? It's like residue, yeah. That's because there's solid chunks inside of here.
It's like
Like glue.
yeah. It's like my catchphrase.
Alright,
I know.
here's an important thing I'm telling you right now. This thing you just saw is called a precipitation reaction. What does precipitation mean? Rain falling. Rain falling. So, the reason this is called a precipitation reaction is because the reaction forms a solid. There's little heavy chunks in here. And if I let this sit long enough, they're going to fall to the bottom, like rain would fall. Does that make sense?
Oh, do it.
So when a thick, chunky substance forms from two liquids, that's called a precipitation reaction. And what's happening is something that was dissolved, it was in solution, came out of solution and it became a solid. That's why you see all these little chunks, the residue. That's solid. If I had poured this through like a coffee filter, all the stuff in here would go straight through the coffee filter and come out the other side because it's dissolved in the water. If I pour this through a coffee filter, all the white chunky stuff will get trapped and the water will go through because this is not dissolved. It's come out of solution. And I don't know if you can see, I'm going to try to walk around slow, but it's starting to fall to the bottom and you can see it's separating. You can see the lighter layer on top. Can you see that? And if I was able to hold still enough, it would all the way sink to the bottom. Because it's a solid that's formed inside. That's what the precipitate is.
Can you grab the solid?
If you could filter it out, if you grabbed with your hands, it would feel like snot. But if you poured it through a coffee filter, it would filter out. Well, we're not going to touch it because there's other things in there.
Touch it.
Oh my god.
So can you see it? When I hold it up to the light, I can see it really well. There's like a stripe, and the heavier stuff is sinking. Okay. So, what was this called again?
Precipitation.
What do you think will happen if I add A to this one?
Bro, stop doing it. I want to slap your face. Give me the strike. I don't care. You don't be throwing my pins.
Okay, I'm going to do it. Are you ready?
Throw it away.
I'm holding A again. What's in here? D and E. And I'm adding A. You ready?
Damn, Victor.
Eyes up.
Are you calling me fat now?
No, she was planning her name.
Why you need a little bit?
Whoa, 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 hold on. What?
What is she her name?
Yeah, hey, break the
Oh, that's cool.
Shake it. What?
Yo,
That's my favorite. Did that white stuff disappear? Is it in there still?
No, I can't see that.
Yes, it is.
It has to be, right? I didn't take it out. So what happened to it? It dissolved again. So whatever A is made it dissolve again because it's clear. It's pretty clear again, right? Like there's hardly any evidence of it at all. All right. Who has an idea about what I should mix in next?
everything.
Somebody wants to see C in here? What did C do last time? Turn pink. What do we think it'll do this time?
Nothing.
Turns brown.
So A is already in here, so you think it's going to do nothing?
Bro, stop touching me.
Okay, let's check it out. I'm actually going to dump a lot of this in there. Maybe the whole thing. And I'm going to do it slow. So right now I have D and E and A, and I'm going to add C. You ready?
You're gonna kill us with these.
So A made it go away, and C made it come back. Which of these chemicals are opposites of each other? The acid and the base are opposites.
That's what it looks like.
So we know A and C are the acid and the base, but maybe we don't know which one's which yet. Who wants me to mix in something else? Any other suggestions?
Put B in there.
Put B in there. What do you think's gonna happen? What did B do last time? Think it'll turn pink? Who thinks this will turn pink?
I feel like a little.
You ready?
It did turn pink.
I killed it.
It turned pink.
It started to turn pink, didn't it? So we know that it probably would have turned it pink if it was strong enough. But failed. I will tell you, B would have turned it pink if it was strong enough. But the acid in here is really strong.
Stop it.
Alright. I wish I hadn't used up all my B. It would have been more fun.
You're gonna kill us.
Sorry, I'm having fun now.
Wait, what are you?
Yeah, that's called fun.
What is that?
So here's the thing you should know. Acid makes the precipitation go away. It makes it dissolve back in the water.
Oh my God.
And base makes it show up.
Acid. A is acid.
So A is acid, and that's why it made the precipitation go away. And it's also why it made the color go away.
And then
The thing is,
C's
what do
base.
you call them?
Is C base? Miss C base.
So I'm gonna let you figure that out right now.
What do you call them?
Alexi, are you asking the off-topic question?
Yeah.
Let's do
I don't
it.
know. He told me that.
Let's do it in a second, okay? The precipitation dissolved
Hot dog.
makes the
Hot
color
dog.
go back to blue. Okay. So your job, you can go ahead and turn that off.